Hey guys, how's it going? I'll again wait for people to come in, make sure you can hear me. Sorry about that little hiccup. I'm not entirely sure what happened. So I guess we'll see. Let me know if you people to come in, make sure you can hear me. Sorry about that little hiccup. I'm not definitely audio and I can hear myself in the background. So that should work. I just moved, let me grab a charger. And we will get started. All right. So again, I'm going to be watching the questions channel, and I need to turn my notifications off. Sorry about the technical difficulties. Because of that, we will just jump right in, and we're good to go. And if you guys could help me, if you see other people asking, saying, hey, there's no audio, hey, the video is not working, that's going to be because of the technical difficulties we had, and we won't be able to change that link, unfortunately. So we're going to get started, and we're going to actually just jump right in. So I'm going to open up my terminal. We should all remember how to do this. I'll say ls. You'll be able to see everything on my computer. We'll cd into dev, which is where we're going to be working out of today. Then we're going to cd into ls web homework 5, where I have some stuff prepared. And let's go ahead and just open this up, first of all, in Sublime, and take a look at it. Don't worry about that shortcut that I just used. We can teach you how to do that later. So what is this? So ls web homework 5 is an HTML file. It's got an h1 with the ID of whatever. It says about me. You probably remember some of this stuff. Just really basic. It links to script.js. Script.js is totally empty. There's a README that is going to talk about some of the stuff that you'll do in your homework tonight. But let's, on the other panel, open that same file up in Chrome. So we'll open a new window. What went away? Did my audio go away? Can you guys still hear me? All right, so here's our index.html. It's the same as everything else, just basic HTML. And what we're going to spend most of our time paying attention to today is the script.js, which we've already linked. We've had a lot of people that have told me they're going to join for the first time today. So if that describes you, just know that we're going to be spending most of our time in JavaScript, and this JavaScript file we're working on is linked to HTML. You'll have to go back and watch that later. But basically today we're going to talk about JavaScript as a whole. We've used it a little bit last week, but we want to talk about what it is and what that means, and I'll make that a little bit bigger while we're talking about it. But JavaScript is built into every browser. And I think I can say that literally. I don't even think there are any weird browsers that don't have JavaScript, unless there's some homemade project. Every major browser has JavaScript built in, to the extent that they even have a JavaScript console built in. So if we go into inspect, we can see actually, if we write some JavaScript code, and we'll show you what that is, the browser itself, without talking to anything else, already knows how to understand what that means. So what that means for us really is that JavaScript has become very popular. Now, it started out as just something built into the browser to make cute animations, and now it can be used to do everything from pilot drones to manage servers, and it's probably the most used language in the world. And that's why we focus on JavaScript, because not only does it help us figure out what we need to do for the front end of our websites, but it can do pretty much literally everything. So now let's talk about what JavaScript means, and even more fundamentally than that, what programming means. So let's take a look at our first program. That is a program. A program is really just a way to issue commands or instructions to a computer. The computer understands those instructions, it knows how to read them, and it will follow your instructions. Most of the programming that we're going to be doing isn't necessarily about issuing commands to computers. It's about controlling which commands we issue to computers and what data we're providing within those commands. But this here is a perfectly valid JavaScript program. What happens when we run that JavaScript program is nothing, because we say, hey, computer, 5, and the computer says, okay, 5, sounds good. But to begin, we can say console.log 5. And console.log, and again, these are connected, we can open what we call the JavaScript console here, and we can see 5 printed out. So this is just our inspect element. We've used this before, but instead of looking at elements, we're looking at the console. And there are a lot of different ways you can do something like this, but I want you guys to understand that this is real code, that it works, and that it communicates with your web pages. So we're just going to be working out of this empty JavaScript file. So we just said console.log 5, which means print this thing to the console. So if we said instead hello, saved it, refreshed over here, the console will print out hello. So we're now communicating through JavaScript with the browser, and we can even write directly to our HTML file from this JavaScript file. So we could say document.write, hello world. We'll save it, load it up over here, and it's pretty small, but you can see right there. I will make it bigger for just a second. Hello world. So we can interact with anything on the web using simply JavaScript. We could even do something like h1, hi there, close the h1, and look at that. We can use JavaScript to print directly to HTML. We talked about that a little bit last time. So now what we're going to do today is going to be diving into the guts of JavaScript. We know that we can use JavaScript to write stuff to our web page, but we need to get really good at wielding those tools and understanding JavaScript as a tool. So first couple things we did involved console.log. A lot of stuff that we're going to be doing uses console.log. And all that is printing to the browser or the screen, or even if we came in here and if we have Node installed, we can run node script.js, and it's going to run that, and it'll print out the same 5 in our command line. Doesn't matter where we run it, doesn't matter how we run it. The important thing is that it works. There's a lot of stuff we can print in here. It's not just 5. We can do math. JavaScript understands how to do math. We'll go ahead and open up the console over here. So it knows that 4 plus 9 is 13. It knows that 4 times 5 is 20. It knows that that times or divided by 3 is something roughly, I guess it's that exactly. It just happens that those are divisible. But there's a lot of stuff that we do with console log just to kind of as a sanity check to make sure that we're printing the right stuff. But let's look at something else that we can do with JavaScript and the browser as well. So we're going to use something called prompt. So we're going to create a prompt in JavaScript that asks, what is your name? So I just refresh, it says, what is your name? I say Austin. Great, that's fantastic. I just said Austin. I may as well have just said, Austin. That's valid. It doesn't cause any errors, but it also doesn't do anything. So what if we wanted to do something useful with the answer to what is your name? Well, we can use something called a variable. So we can say var, which stands for variable, my name, and that can be anything. As long as it's not a reserved keyword, this will work. We set it equal to something, and it's going to collect, when we refresh here, the name. So let's, console.log my name. So now we get a little bit of our first interaction with the user. So we're going to ask the user, what is your name? The user says Austin, and then we're logging that to the console. Or alternatively, we could write that to the web page. My name's Austin, and it's hard to see because it's really small down there, but it did just write, we'll actually make this really big. It did just write Austin down over there. So we can do any JavaScript that we write, we can make it work however. So here's what we're looking at right now, is this thing called a variable. A variable we write by saying the keyword var, always has to be var, V-A-R, then we make some name. That can be whatever we want, and then we set that equal to something else. So maybe we say 5 plus 9. So when JavaScript comes through, it's going to start at the top, and it's going to figure out what 5 plus 9 is. It will know that that is 14, and then anytime you use some name in JavaScript, it knows that that is going to be 14. And we can use that in a lot of different ways. We can write that to the console. We can use that in a web page. We can combine it with something else. So we could say document.write, hello, I am plus some name plus years old. And we're actually going to space there. Hello, I am 14 years old, just printed. So backing up a little bit, with regard to JavaScript, there are a few different what we call data types. At the end of the day, everything we do in programming is data. So we have strings, and that's basically just letters or text. That can be HTML. It doesn't really matter. String is just really a way that we say text, for lack of a better word. There's numbers, and we can do arithmetic with those numbers. There are operations, and you're probably familiar with a lot of them. We can add, we can divide, we can multiply, we can subtract. And all of those are valid JavaScript. We could console.log each of those, and they would work. One of the ones that we want to focus on a little bit today, because it's going to be important in the programming challenge, is called the modulus. So if we say 9 divided by 5, take a minute back to, it's probably 3rd grade, and instead of using a decimal, we would say something like, well, 5 goes into 9 once, and there's 4 left over, so we would say it's 5, remainder 4. Or if we said 13 divided by 3, we would say, okay, 13 times 4 is 12, so we would say 12, remainder 1. What the modulus does is, instead of saying, giving us a remainder, and it's just the percentage sign, 9 divided by 5, it's just going to give us back 4. Or 13 divided by 3, it's going to give us back 1. And why do we ever want to use that? Well, what if we want to see if something is divisible? Well, let's say if it's even. So let's do this. We could say 9 modulus 2 equals 0. And actually, I'm going to jump back in and take some questions because we're going through a lot of this right now. No audio for me. Got it. We can hear you. Working like a charm. All right. Just so I know I'm sane, let me know if there are any audio problems going forward. But we don't have any questions, so we'll keep plowing forward. So JavaScript is really, the same way HTML and CSS are kind of an empty canvas for us to do whatever we would like with them. JavaScript is very much the same way. So we talked about numbers. Now let's go back into our examples. So if we wanted to print the remainder of 14 divided by 3, which we know 3 times 4 is 12, and then there's 2 left over. So this will print out 2. And if we do 15 divided by 3, what do you guys think that'll be? Go ahead and comment in questions. That would be 0, because 15 divided by 5 is 3, and it goes in perfectly. So that is the modulus. So now let's combine a little bit of the modulus and variables. So let's say var my number equals 5. So we just chose a number and said that it's 5. Now let's say var second number is 14. So we have 2 numbers, a second number and my number. So let's see what happens if we do console.log a second number modulus my number. And we'll get rid of all this stuff up here. What do you guys think that will be? So you can see that it's 14 modulus 5. So 5 times 2 is 10. There's 4 left over. So the answer to this is going to be 4. 4. There we are. Now, what is the difference between these two things? Why don't we just say 14 and 5? Will that be the same? And the answer is yes, but going back to the other example, what if we wanted to take input from somebody else? Or what if we were using this my number all over the place? So what if it were the number of followers that somebody had on Twitter and you wanted to display it on 15 different pages? You don't want to calculate that 15 different times. You just want to store it and have it ready. And then you can just say, all right, get that some user's follower number, and we'll write it to the page and we'll display it. And that is the basics of how we use variables. Variables are just a way that we can store things. And we say var, we create a name, and then we set it equal to something. So we could even say, here we have, we want to calculate 14 divided by 5. Maybe that's 14 modulus 5. Maybe that's messy. So we're going to say var equation equals 14 modulus 5. And then we have a new keyword that we can plug in right there, and it will work just the same. I'm going to jump back into questions, see if, let's see. Can JavaScript do complex math and algorithms? Yes, it absolutely can, but there's some caveats we will get into later as far as what those limitations are. I can't imagine you would run into them for now, but yeah. In C++, equals means a sign, and equals means equal. What about JavaScript? Is there a rule for that? We're going to get into that in just a second. Is it too far ahead to briefly explain var, let, or const? Yeah, for now we're just going to use var. So let's get into testing equality. And the way we're going to do that is with an if-else statement in the beginning. So JavaScript not only can give instructions to our computer, it can test things. So we can say if 5 equals 3, and we'll explain this equals in a minute, but that's the true meaning of the word equals. Console.log 5 is the same as 3. So What happens if we run this? Nothing, because 5 is not equal to 3. So JavaScript knows that if we're using if and then brackets, this is the first statement. So if 5 equals 3, then do this. And if not, else, you can create another block of code, else console.log, they're different. So let's run that, and obviously they're different. Now, what if 5 equals 5? We refresh. 5 is the same as 3. Well, 5 is the same as 5. We have to change that message there. So a lot of you, I'm sure, are going to ask, what is the difference between equals, 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 and equals? So equals in JavaScript, a single equals is an assignment. So var sum var equals 15. We're not necessarily setting those equal to each other. We're just creating a box called sum var, and we're putting 15 inside of it. So we could come down here and say sum var plus 5 console.log sum var. Oh, sorry. Sum var equals sum var plus 5. So here we're saying, okay, let's say we're going to comment that out for now. We're going to create some variable, say that it's 15, and then we're going to take that variable and say now this variable is set to that variable plus 5. Mathematically, this both can't be true, right? You can't have something be 15 and be 15 plus 5, but it works. And why does it work? That's because this isn't actually an equal sign. This is just an equivalency sign. So we're just creating a box called sum var, and we're saying put 15 in that box. And then here we're saying, hey, remember that sum var box? Actually now we're going to take whatever's currently there, add 5, and assign that to a new sum var box. So sum var is now 20. Now what is this triple equals sign? So this is just saying if 5 equals 5, then this, else this. What if we do 2? Well, that will actually also work. And here's why. So the first equal is just setting. Just remember that that is how you declare what a variable is. 2 equals will test if something is equivalent, but not considering type. And I'll show you what that means in just a minute. And then 3 is equivalent, including type. What do we mean by type? So we could say if this is the letter 5, or not the letter 5, but this is text that says 5, is that the same as the number 5? Let's test it out. If we use 2 equals, it is the same. If we use 3 equals, it's more strict, and it's going to say they're different. So this letter 5 is not the same as the number 5. In other words, this is a string, which we talked about is just a set of letters. This is a number or an integer, so we're going to be strict about it, and they're going to be different. Does that make sense? So again, we've got 1 equals to set equal. We've got 2 to test equivalence, and type doesn't matter. And then 3 will test equivalence, type matters. And just because that's driving me crazy, we'll get rid of that, even though it's not grammatically correct. So that is how we can use an if statement. So we could do something like this. Let's write our first simple program. Let's say prompt, what is your name? And that's just going to ask what someone's name is. So we want to store that somehow. So let's say var my name equals prompt, what is your name? So Austin. Now my name, until I refresh, is saved as Austin. So we can, let's do console.log person set their name to, and then we'll just plus my name. And in JavaScript, that just concatenates those two, so it combines into one large string. So let's run this again. What's your name? Austin. The person set their name to Austin. That's great. Now what if we wanted to write this to the page, but we only wanted to write it to the page if the person's name is Austin? We would say if my name equals Austin, document.write, hey there, Austin. I'm going to say else, document.write, who are you, stranger? So let's run this program a couple times. So let's go over it briefly. We create a variable called my name, and we set it equal to, and this is just the way this works, the response to the prompt. So when we have this prompt, what is your name? Whatever they type into the box, that's what's going to be saved as the variable. So first we log that to the console. So we're going to say this person set their name to Austin. And then if my name is Austin, write, hey, Austin. And if not, say, who are you, stranger? So let's give it a shot. So the thing pops up. What is your name? Let's say it's James. The person set their name to James. And the text here reads, who are you, stranger? Let's run it again. What is your name? It's Austin. The person set their name to Austin. Hey there, Austin. So as you can see, using really simple JavaScript, we can actually, if you wanted to create a game that responded to people's, what they said to different questions, you could do that using JavaScript alone and write out the responses to HTML and CSS, and it would work beautifully. So, we've only been going over this a few minutes, and we've already gone over some really cool stuff. So what if we wanted to test a couple things? We could say else if my name equals James, and then I see you are James, else I don't know who you are. Oh. So we can do a lot of different things. We can test all sorts of stuff. I'm going to make this just a little bit smaller for now. And again, JavaScript is just a blank canvas that gives us a lot of tools that we can work with. The last tool that we're going to go over today is something called a for loop. And I've talked to a lot of people over the past couple weeks who have been really frustrated by for loops. And for loops are actually really simple. And all they do is they help you count from one number to another number and do something with each count. So let's explain what that means. So let's say we have a variable called counter, and it's equal to 1. And we wanted to say, okay, each time the counter increases, print that to the screen. So we do document.write counter, and then we would say counter equals counter plus 1. So we could repeat this again and again and again. And what we see here is we started with counter, and then we wrote a 1 to the screen, and then we said, hey, the counter, let's make that 1 bigger. And then so now it's 2, right? We know that the counter is 2. And then we wrote the 2 to the screen. Then we added another 1, and we wrote the 3 to the screen. A for loop basically lets us make all of this a lot more concise. So let's say for we already have counter. So let's say var counter equals 1. And instead of counter, we're going to say, just call it I. And that's usually the context that is used in a for loop. So we'll say for var I equals 1, I is less than, we'll say 10, I plus. And let's do document.write I. I know this is a lot. We'll go over it in just a second. So let's see what this is doing here. So here, the way I want you to think of a for loop is you write for, and then you put 3 things in it inside of parentheses. And this is where to start, where to stop, and how to get there. And it's really that simple. So with this for loop, we say I equals 1, so we're going to start at 1. And what this does is between 1 and whatever we say here, the stopping point, so when I is less than 10, we're going to perform this action for each I. So let's go through that really slowly. So to start out, we have I equals 1. We just set it to that. It's going to go through and say, is I less than 10? Well, I is 1, so it's obviously less than 10. Let's write, so this is valid, let's write it. Okay, it writes a 1. Now I plus plus, it's going to increase itself by 1. That's just we could say I equals I plus 1. It's the exact same thing. It's just shorthand. All right, let's go ahead and do it again. Now I is 2. So I is 2. Is 2 less than 10? Yes, it is. So let's write it, and let's add another. Is 3 less than 10? Yes, it is. Let's write a 3, and let's add another. Is 4 less than 10? And it keeps on going until it says, okay, is 10 less than 10? No, 10 is not less than 10, so it just stops. And that's the end. So what if we wanted to, instead of starting at 1, if we wanted to start at 0, what will happen here? I'll make this quite a bit bigger. Well, it's going to start at 0 this time instead of at 1. Oh. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What if we started at 4? Now we start at 4. What if we start at 8? So this is the starting point. I'll just write down here a comment for start, stop, how we get there. Do this each time. That's all a for loop is. So if we say for var I equals 2,000, I is less than 4,000, I plus equals 2. That's just going to say increase I by 2 each time. Let's see, document.write I, and then just to make things clear, we're going to put everything on its own line. So we're going to add a break as well. So we start at 2,000, and we say, okay, is 2,000 less than 4,000? Yes, then write 2,000 to the screen. Okay, let's add 2 to I, and we start the loop again. I is 2002. Is 2002 less than 4,000? And as you can see, this would be terrible to do manually, but your computer is really fast at executing really slow or really simple things. One of the things I want you to notice here is we do not include 4,000 because we're saying is I less than 4,000. So by definition, 4,000 is not going to be less than 4,000. If we wanted to include 4,000, we could say I is less than or equal to 4,000, and that would work. Let's go back into some questions. Can you explain type and not including type a little bit more? That's a really good question. So one thing that you need to know with programming is everything has a type. So if I say hello, JavaScript recognizes that this is the type string, or you can think of it as type characters. If I say this, JavaScript recognizes that this is a number. So what is the difference between this and this? Well, JavaScript will render it the same most of the time. JavaScript has a few quirks, but that's not always true. So if we did equal equal here, it would work. If we did equal equal equal, this would not work because even though they're the same thing, they are of a different type. And other languages that you'll use later, type is a lot more strict. So in some languages, you couldn't even, just use this. You would have to convert it to a number first. But JavaScript is really loose with how it treats types. So there are, a few types. Another one is true or false, and we call those Booleans, etc. So, and I didn't explain this very well. So what is the difference between, so what are we doing when we say I plus equals 1? We're just saying take I and add 1. Another way that we can do that, since we use that so often, JavaScript actually has another shorthand, and as do a lot of programming languages. We can say I++. We can also say I minus equals 1, and so that's just going to take I, and that's the same as I equals I minus 1. And you can also use I minus minus for that. And you will have a lot of practice doing that with today's homework. So let's actually do a for loop that decrements. So let's start at 100. And let's count down. So we're going to say I minus minus, and we're going to write it. Now, we want to be really careful here because what happens if we say, okay, let's start with 100, and let's subtract 1 each time. So we're going to run this loop for 100, 99, 98, and we're going to run it for as long as I is less than 4,000. That is what we call an infinite loop, because this is going to start at 100 and keep going down, which by definition is always going to be less than 4,000. So we're just going to run forever. What happens if we do that? Well, it's not going to load because it's just going to run forever. And if I let it run for long enough, it'll either error out or kill my browser. So I'm going to fix that real quick. And I may have just caused a memory overload within my browser, so that's great. All right, we're back. I almost killed everything for a minute. So if you are running a program and nothing loads and your computer crashes, there's a decent chance that you have an infinite loop somewhere. Obviously, that's not a good thing to have, and it's something to try and avoid. That's another good question. What if there's a syntax error or other type of error? What does JavaScript display? So let's say we have that. Well, in this scenario, it's just not going to write anything. But if we go into the console, it's going to say unexpected token equals, which in this context, that just means, hey, something is broken. Someone asked, what does it mean to increment something? Increment is to take something and make it bigger or smaller, usually by 1. So all that we're doing here is we're saying start at 100 and I minus minus, so we're going to increment by 1, or by -1. So 100, 99, 98, 97, that is incrementing by -1. The same way if we were doing I++, we started at 100, 101, 102, that's incrementing by 1 in the positive direction. So let's do another. Let's say we wanted a loop that started at 400 and it went to 2, and we wanted to do it by decreasing 5 each time. So we're going to do 400, 395, 390, etc. we'll do it until it's greater than or equal to 32. Why not? And we're going to write that, and it's really big. So go 400 is 400 greater than or equal to 32? Yes, it is. So let's write it. And then after that, we subtract 5, 395, and we keep doing that again and again and again until we get to 30. It's going to check, is 30 greater than or equal to 32? No, it's not, and it's going to stop right there. I want to take a minute and see if there are any questions regarding for loops, because a lot of your homework today is going to be about for loops and how they work. And just as an experiment, we're going to try to create something really cool using a for loop. But I'll wait for just a second to see what the questions are regarding for loops. Is there any particular reason we would increment? Yeah, we'll show you an example in just a minute. All right, it looks like that might be it. So let's say we wanted to take a number, var some number, maybe it's 8, and we wanted to print exactly this. This is a challenge that you will likely, well, this type of challenge you could definitely see in a coding interview. So what it's going to say is start by printing one pound sign. I refuse to call that a hashtag right now, but 1 pound on the first line, 2 pounds on the second line, up until you reach this number. So how would you do that? Let's give it a shot. One of the things that I want you guys to get really good at in programming is thinking about things from the top to the bottom instead of from the bottom to the top. So instead of saying, okay, I know we need a for loop, we're going to go through and we're going to step through everything that we might need to do, Octothorpe, yeah. Everything that we might need to do to solve this, and we're going to write it out in pseudocode, and then we're going to take the pseudocode and replace that with real code. So I'm going to say start with 1, and then skip a line and keep adding 1. We'll keep adding as many as our iterator up until we are at 8. So how would we create something like this? So let's start with 1. So for var I equals 1. And then we're going to do it up until we're at some number, right? So now we know that we can do this I less than or equal to some number. And how do we increment? We do I plus plus. So there's our for loop. We'll see if that works or if we miss something. And then what we need to do within this is we need to print some number of octothorpes. Thank you, Mixelpix. And then skip a line, basically. All right, so how would we print some number of octothorpes? Well, let's create a blank screen, or a blank string that we can start with. Var line equals this. And for right now, let's just say document.write line. And then at the end of each loop, we're going to say line plus equals an octothorpe. What does that look like? Well, basically, we get all of these different octothorpes. How do I make this bigger? We'll get rid of the console for now. And we have a pretty good number of them, it looks like, but they're not on the right lines. So one way that we could solve this is by using console.log. And if we go into the console, there we are. We've printed 1, 2, 3, 4, 5, 6, 7. Uh-oh. What happened here? We didn't print the 8th because when it was 8, no, that should work. 1, 2, 3, 4. We'll get into that in a second. So we cheated a little bit here because console.log automatically adds a line break each one we're running. But let's go back to document.write. And we can just do this, right? So we can add a manual line break at the end of each line. Oh, but then we get something like that. There we go. So the problem here was we were writing a line break every time we added new octothorpe instead of doing it only once at the end. So this is the kind of practice that you guys are going to be doing a lot. Just writing a lot of for loops, and it's possible that some of this didn't sink in and it won't until you write a lot of for loops. That's the difficult aspect of programming. Let's see. 1, 2, 3, 4, 5, 6, 7. So to solve this, we could do one more document.write line. That's what we call an off by 1 error. So why did we not print this 8 times right here? Well, it's because we ran through it and we said, all right, every time we do this, we're going to print it. We have 7. And then we said, okay, now the line plus equals an octothorpe. If we were to console.log right here, the octothorpe, we would have 8, but we never write that again. So we have to write it again outside. This probably isn't the cleanest or the most concise way to write it, but this definitely works. So a couple things that I want you guys to take out of this, because I don't expect you to be able to write a for loop like that right off the bat, is starting from the top down, thinking about take the entire problem you have, break it into smaller pieces, and then solve those pieces independently. For some of you, if you've never written a for loop before, it's going to be hard to write a for loop in general. What if you started with var equals 0? That's a really good question. Aha. That's another way we could have done it, because we're adding this line before we print, so that would work as well, I believe. Yep, that also works. What if we, and here's the really cool thing, what if we wanted to do this for 1,000? What would that be? It's gonna take a minute. It's running through 1,000 loops. There we go. 1,000 octothorpes on the bottom line. So you can see how programming can be really powerful. Can you imagine writing all this out by hand and trying to figure all of it out manually? And we could even do something like 800 modulus 3, which is apparently 2, because that's how many it prints out. So again, we have all of these superpowers that we can use, and now you can do a lot of stuff. Somebody asked, do you need a semicolon in JavaScript? You should. You don't a lot of the time, and it's definitely best practice to use them. Sometimes when I'm just sketching like this, I forget, which is really bad habit. Don't get into do that. But technically you don't, but you definitely should use a semicolon at the end of every line, if for no other reason than figuring out what went wrong when something is broken. So your homework for today is going to be writing a lot of JavaScript. We can go over this until I'm blue in the face, but it won't help you until you are writing a lot of JavaScript. So we're going to start out by doing some basic math, getting comfortable with the syntax a little bit, and we're actually going to get into a problem that is called FizzBuzz. And that is going to be really difficult and combine everything that we've done so far. And in the technical interviews I've done, probably 20% of people can solve FizzBuzz on their first try, which is just atrocious. That's something that every programmer should be able to do. And I have never hired a single person that didn't code FizzBuzz correctly. And it's probably the most frequently used technical challenge that you'll ever see. And this is basically what it is. So FizzBuzz says, let's start. I want you to print out by starting at the number 100 and print out each number down to 0. You know how to do that, right? That's just a for loop that starts at 100, and then it keeps going until I is greater than or equal to 0, I minus minus. That part's easy. Now what FizzBuzz does is it says if a number is divisible by 3, I can't remember all the details. If it's divisible by 3, replace it with fizz. No, that one's not divisible by 3. 96 is. Replace it with fizz. If it's divisible by 5, replace it with buzz. And if it's divisible by 15, replace that with FizzBuzz. So basically, you have this long line of numbers that goes, buzz 99, 98, 97, or I guess it would be something like this. And then every once in a while, you run into FizzBuzz. And someone's calling me out for saying we won't do math. No, I said you won't need to do any more math more than arithmetic or understand anything more than basic arithmetic, which this is all basic arithmetic. The hardest thing we're doing here is a remainder or counting from 100 to 0. So you should be all right. If not, then I'm not sure what to tell you if you can't count from 100 to 0. We've got other stuff to figure out. But that will be your homework for tonight. I know it's going to be difficult. So to give you a hint, you're going to have to use an if. If something modulus something else equals 0, else if, else. But FizzBuzz will be a fun challenge for you guys. Definitely, get used to solving it. Maybe try to solve it a few different ways. It might take you a lot of time. It might be really easy, but it's a really good challenge for combining a lot of these things. You have to use loops. You'll have to test for equality. You will have to know how to increment. You'll have to know how to use the modulus. So yeah, that will help you out. I think that's it for tonight. I'll stick around and answer any questions on Slack. But thanks for joining us, and enjoy writing the first real JavaScript.